Hey, time for another big hairy monkey video on metalworking, specifically jewelry techniques. Today I'm going to talk about soldering. I have a coronet project for a client, and they have asked me to attach twisted brass wire as trim on the coronet. So what I'm going to do is walk you first through surface prep, and then this one will probably be a slightly longer video. Surface prep, and then some materials used, and some the techniques. Or probably I'm just going to use one technique. So the technique. There are a ton of soldering techniques. There's a awesome thing called brazing, which I just learned how to do the other day. But we're going to talk about soldering today, and I'm going to push pause a lot because I have a lot of stuff to do, and it's going to be boring to watch. And I'm not a great video editor, so I'm not going to be able to like speed me up and go, fast motions or any of that kind of garbage. It's just going to be me and push and pause once in a while when I've got to do a lot of, behind the scenes stuff that cannot be done. Like I can't do mise en place for my whole soldering technique. There's got to be like little mise en place, some talking and some videotaping, and then a little bit more and so forth. And so every time I'm doing the mise en place, that's a chef's term, by the way, for having all of your things in place before you start cooking, having all of your ingredients chopped to the right sizes and laid out in little bowls. And you'll see a lot of TV chefs doing that, and that's kind of what I'm doing, but I'm doing it on the fly. So first thing we're going to talk about is surface prep. This is my client's piece. As you can see, it is polished to a fairly well. There's my monitor on my computer. I keep a computer on the workbench, and it's got my MP3 player up. So you can see the surface of this is polished really, really well. But having just come off the polisher, it has polishing residue still on it. And no matter how hard you try, polishing residue is the enemy of soldering. The waxes and oily stuff in polishing compounds. I use buffing wheels and stuff like that. I don't really like to polish by hand, except for right at the end. I like to, rub the remaining like fingerprints and stuff. Oh, also rubber gloves, latex gloves. You buy them by the box from Harbor Freight. They're inexpensive, and I can touch the edge of this all I want and not get fingerprints on it and not have to polish out fingerprints. So surface prep, polish it like this is all the way through final polish. This is as shiny as the piece will ever be. And the reason I do it, I take the metal, I make the shape of the coronet, and then I polish it as far as it can possibly be polished, because every single thing I put on the surface, if I put pearls on the top are less interfering, but every other thing I do to the surface of the coronet gets in the way of my polishing wheels and creates what I like to call a shadow. The polishing wheel, if this is my polishing rod, if this is the rod that I have just soldered onto the edge of the coronet, when this polishing wheel is going by trying to hit the surface of the coronet, there's a little shadow right in here where it can't polish. You generally can't get the buffing wheel in there to polish that. And this is probably, this fist is representing something maybe 2/16 of an inch thick, something like that. But it creates a little shadow, a little void in there where the polishing wheel cannot get to easily, and polishing compound will build up in there, because I will go through and polish. This is, although I've taken it through final polish, I'm going to polish it 3 or 4 more times. Every time I put another thing on it, I'm going to polish it. So I will put, he wants 3, this client wants 3 accent wires soldered. You know, he didn't specify soldered or not, but if you're using twisted brass, if you're using like a half round or something, you can rivet that onto the edge. But if you're doing twisted wire, there's no real good place to drill through it to put a rivet. So it's got to be soldered. Once again, I'm saying it multiple times, surface prep, what you're seeing me doing is folding paper towels. And the reason I do that is there's wax, there's a actually invisible to the naked eye layer of wax on the coronet. And that's got to be removed before, I guess you could flux it, but I've found that when I apply heat, any residual surface wax will burn if I haven't washed it off. This is ammonia, you know, household typical floor cleaner, whatever ammonia. The awesome thing about it is it dissolves wax. So I take the cloth, paper towels, whatever you prefer, and I'm just gonna wipe, and you can see it's already, I mean, it's not much, but it's bluing up some from the wax. So because this is nickel, I use a blue polishing compound as my last stage. The blue stuff is the finest grit wax-based polishing compound that I own. And so I just kind of carefully wipe away the residue. And there's the joint where the pieces solder together. I always start my wiping and such to clean up the, not when I'm soldering, and I'll tell you why in a minute, but I try to, like when I'm polishing, I will always start at that joint because it's easy to tell, okay, I've made a lap. Okay, I've made a second lap, however many times you have to go around a piece to get it polished to the right consistency. So you can see this is a little dirty. There was just a little wax on there. And that and that will completely, that minuscule amount of wax will interfere with your soldering. Next I have 91%. Oh, cool. Look, my camera's making everything look backwards. Excellent. So I have some 91% isopropyl alcohol, 91% concentration. It's, 91 parts alcohol, 1 part water. I wiped the residual ammonia because it, you can see it. It's hard. You can't see it on the camera, but when you're doing this, you can see the ammonia because it's thinned with water some of it is staying behind on the surface of the metal, and the residual ammonia will both by itself interfere with the soldering process, as well as it carries just a tiny bit of that wax, which is still bad. So now I've wiped it down with alcohol, and you can see even more. Oh, there's the lens. You can see even more residue, right? Alcohol is a pretty good cleaner, but even alcohol leaves behind a residue, and I have had enough awkward, sketchy, weird things happen when soldering that, you'll apply your flux, you'll apply your solder, you'll apply your heat, and instead of flowing like the solder is supposed to do, like magic, the solder will pearl up because it's, whatever invisible amount of surface residue is preventing the solder from flowing, even though you've used flux, which is a mild acid-based solution that is supposed to clean up the metal and provide a good place for the solder to flow. This last is acetone. Acetone's awesome. It's very volatile. You can find it in nail polish remover, but don't use nail polish remover because that's got perfumes and stuff in it that will residual waxes, residual things on the surface of your metal that will prevent solder flowing. And this might, you might actually legitimately get away with calling me anal retentive about this, but I've been doing this for 8 years, coronet making professionally. And, this one, see what I did there was I reached around and I wiped the inside of the coronet, and that's where this massive black spot just came from. That was not on the surface of the coronet, but I'm not going to use this side of the paper towel again. I'm going to put some more acetone on the other side and finish my cleanup. And you can, you can watch the acetone evaporate. It's very, like I said, it's very volatile. You can watch it evaporate away off of your metal. This metal is now what I would call kind of clean. It's not, obviously it's not pristine and perfect, but it's kind of clean. All right, I'm going to push pause for a second and I'm going to get some things together and I'll be back in a moment. And we're back. That didn't take as long as I thought, but it's still, it would have been awful for you guys to watch me dicking around for a couple of minutes while I pulled things together. There's a good chunk of equipment required when you're doing soldering. Some of it's nice to have, some of it's pretty mandatory. Nice to have some sort of, a lot of people use charcoal blocks. This is some other, I don't think it's asbestos, but it's some other fire resistant, it's a soldering block. And I put it on my bench pin. I'm going to change the angle of the camera slightly. Oh, I should do this where I can see it. Cool. There we go. Now you can see my working surface. I have a bench pin. I like to so the bench pin is, there's a space underneath it. It's hanging off the edge of my workbench so that I can take the coronet and hang it off the workbench like that and solder just right here when I'm working. The next couple of pieces of equipment are, I have, this is your Smith brand, what they call the little torch. It makes a very tiny, very hot little flame. It's pretty nice. I've got the, this is a very heavy chunk of steel and a magnet, and my torch will sit connected to the magnet. So when I need to put my tools down, I don't necessarily have to turn the torch on and off every time. This is a cool little thing. It's an electric igniter. It makes a tiny little spark right there in the center. Maybe we'll be able to see it. Yeah, there it is. Sparks. Those light my torch for me. It's really convenient. It's better than the, the Bernzomatic thing with the flint that you have to go and it makes sparks and it lights your torch. And those aren't really useful. They can be done, but they're overkill for a little tiny torch like this one. Like I said, I've got the brass rod that I intend to use, and I have here. You can see them floating around inside here. A bunch of tiny little pieces of silver solder. And for the benefit of Mistress Morgan Athery, that's really silver solder. It's not Stay Bright. I know you hate that product. Even though it says it's silver bearing, it's probably like 5% silver. And I have finally, all the talking to me you have done about silver solder and getting the right product, I've stopped using Stay Bright. And I've got the brass rod, and I'm just gonna, it doesn't need to be, I'm not gonna clean it as thoroughly as the coronet. I probably should, but I'm not gonna. Oh, nice, a kink. The kink doesn't matter. It just, I don't like having them, but it's neither here nor there. Down here on the floor where you can't see them, I have a oxygen tank about this big, and I use Coleman propane. Because it's cheap. So take take the coronet, take the brass. Oh yeah, I wanted to talk about this. This is the brazing joint. Looks pretty good, don't it? This is the brazing joint on the coronet. What I like to do, because I put the pieces of whatever I'm attaching to the surface, I don't line them up with the brazing joint, because a gap in this lined up with a gap in that is just going to visually draw everybody's eye to seeing how it's all put together. And if I don't have to show you how the sausage is made, I'd really kind of rather not. Oh, this stuff isn't... you give it a little bit of flex, right? You bend it a little bit just to get it. And then I just do this for the very first joint, because otherwise I'm going to be fiddling around here for a while trying to make things line up correctly. I have a C-clamp that I've ground a groove. The top bit of it has I've cut a groove into it. And that is so that when I set it all together, I'm gonna hang it off the edge of the block, and there's the notch in my bench pin where the clamp is gonna go, and I'm gonna put the clamp a bit away from the actual solder job for a very specific reason. The clamp is ductile iron, and it will act as a heat sink. And you need to heat. Every instructor online is going to tell you you're not heating the solder when you do a solder joint. You're heating the metal around the solder joint, and that makes the magic happen. That makes the metal flow, the solder flow. All right, I'm going to push pause again while I set this up. Whee! That was a fun ride, wasn't it, kids? I'm going to push pause and I'll be back. Okay, we're back. I've decided to bail on the clamp because it was fighting me on the connection, and sometimes I get frustrated and decide it's just not worth messing with. So first thing I'm going to do is I'm going to light the torch. We'll put this here where you can see what's going on. Hear the clicking. Turn on the gas just a little bit and I get a flame. And I turn up the oxygen until the flame is just... This is what they call a hard flame, where your oxygen's pretty high and your blue tip is very short. This is a soft flame where the blue tip starts to turn a little orange. And because it's not super high temperature solder, you don't really have to worry about a hard flame. I go with a soft flame. And I put on this excellent product called, I'm going to move the brush, Handy Flux. And once again, the words are backwards. I don't know why cameras do that. But anyway, Handy Flux. Handy Flux is a great product. It's like a white solid. You put some water in there, it makes a paste. And I put it on both the end of the brass rod and on the surface of the nickel. And like I said, it's slightly acidic, and it where you put it is where the solder is gonna flow. And I take one little piece of the silver solder, and I place it, and I put the brass rod right where I want it. But my hands aren't very steady, right? Because I don't know why. Which is why I wish the clamp worked, but it didn't. So I'm going to relax a little bit, I'm going to breathe, and I'm going to start heating. And I'm really hoping to heat the brass rod and the nickel at roughly the same, bless America, roughly the same rate. And get them up to the flowing temperature of the solder itself. it really does, for me anyway, help if I have my limb braced where it can't move as much. Ah, that's better. And I'm like, it looks, I don't know if I just know what works for me, so I might not be doing this right. But what I'm doing is I'm definitely following the instruction that many many of the videos that I've watched to teach me how to solder better have taught me, which is you're trying to heat the metal, not the solder, because that is in fact a great way to get the solder to just pearl up and not do what you want. And the other lesson is that the piece of solder that you put down has to be touching, piece of solder has to be touching both surfaces that are being soldered. Otherwise, it's going to flow beautifully across one, but not both. And turns out that metal conducts heat. Shocked. I can hear you all going, what is he talking about? It does not. Yeah, metal conducts heat. I learn this every time I'm making something. I let he who is without second degree burns on his thumbs cast the first stone. Anyway, so the silver solder is touching both the coronet and the rod, and it's starting to pearl. Oh, and I just flipped it onto the floor. Because, you know, I'm on camera, and that's going to make the demo go so much better when I'm throwing pieces around. So I used my tweezers. I picked up another piece. I put it down. I realize it's not in contact with the rod. It's just in contact with the coronet, which will lead to a less than satisfactory outcome. And I go back to heating the metal, not the solder. Wow, this is a long video. But here we go. There's a pearl. Which probably means I'm doing it wrong. Nope, and it's flowing. And it's flowing, and the brass rod is glowing red. And I've done something wrong. Because I can vaguely feel the rod not sticking. But the solder flowed beautifully, so it's probably not any sort of failure of cleanliness or anything. The solder, there's a little spot of solder on the coronet now that will polish up nicely, but shows that I definitely did a good job cleaning, and I just didn't get a good solder joint. Oh, that's beautiful. That's going to make a mess. So I just touched I cooled the brass rod with some handy flux that I was applying, and I'm burning it off, and handy flux goes through like a stage where it burns off and becomes kind of ashy, and then turns to almost glass looking. Come on, little guy, I see you doing the thing now. Now maybe this worked. Let me turn my torch off, and I'm gonna let go of the rod. Ta-da! That's a solder joint. It's messy when you look at it. Where I've heated the brass rod has turned kind of black. It's hard, you know. I don't want to pick up the camera to show you, just because I don't know how well it will look on camera. And there's heat like when you heat something as it goes through color changes as it's getting hotter and hotter. There's the rings of the expanding heat on the surface of the metal, and then there's the spatter where the liquid handy flux, or when I touch the brass rod back to the very much hotter coronet, the liquid, the water in the handy flux boiled, and some of the handy flux spattered onto the surface of the coronet. When I'm done, I'm not worried about it. When I'm done soldering, I will be dunking the whole piece in some pickle, and that will dissolve the solder, the flux on the surface, and then I'll dry it off, and I'll let it dry overnight probably, and then when I get back to the buffing machine, it'll all come off and we'll be back to bright shiny metal again. So that was soldering. I'm sure there's going to be a bunch of questions, and I might want to post this one to YouTube instead of putting it just on Facebook, and then just post the link right there. So I think that's what I'm going to do. But thanks for watching. Thanks for being part of my love of metalwork, and I hope this is helpful to you guys. Maybe I should show you the second joint. All right, so it loses its heat pretty quickly, and I move, because it's an edge wire, I move about 1.5 inches, I guess, and the rod is kind of, it's annealing as it goes along, right? So the brass rod gets softer as you're moving. And so what I'm going to do is I'm going to put my glasses back on so I can see what I'm doing, because I am half blind. And I'm going to put some more flux on the rod and some more flux on the nickel coronet. And I'm going to fire up the torch again. One of the things I like about the little torches is the valves are easy enough to turn with one hand, so I can pick the torch up, turn the gas on, light the torch, get it going, and I can do that all with one hand while I'm holding pieces together, or the other stuff. So, and then following the same procedure as before, I'm going to sort of burn my thumb when the heat flows down the brass rod, but I'm going to boil off the flux and get it to this sort of glassy state. It really looks like melted glass, molten glass, whatever, on the surface of the metal. I'm going to put, these are, I guess, called pallions, P-A-L-L-I-O-N-S, pallions of solder. I'm going to put one of those in, once again, in contact with both the nickel and the brass rod. And I can see it's moving, right? So that means there's still a little bit of water in the flux. It's boiling off, and the steam causes the solder to move. And experience has taught me that that's a thing to be avoided. And now I can see the solder, the pallion moving, like it's sort of hopped a little closer to the brass rod. And I can also see that as the brass rod is softening from the heat treatment, how I said that it kind of anneals as you're working, the weight of the rod over there in the distance, I'm not looking at the camera, so I'm just guessing you can see what I did, but that is pulling down on the rod and making a bigger gap appear between the rod and the nickel, and the rod is not in contact with the solder anymore. And so I fixed that by, I'm now supporting the weight of the rod with my left hand. And I'm just waiting for it to heat and flow. I don't have the torch turned up high enough, maybe. Oh, I can see. You can sort of see as you're heating, the solder goes from this sort of dull color scheme, dull appearing surface, and when it's starting to reach temperature, it gets really shiny. Cool, that's the second solder joint. And I'm just going to continue to work that around the edge of the coronet. One of the things I do is, as I'm fitting it, I will sometimes bend in the opposite, like if I was riveting in particular, it's much more friendly to do it because it's not, we have a rule in the shop, which is just because it's stopped glowing doesn't mean it's not still 900 degrees. And if I touch that, it would burn a hole in my glove, and it's cooling rapidly, but it still can be right when you lift the torch, it's bloody hot. This silver solder flows at over 1,000 degrees C. So yeah, it's hot enough to burn you badly before you even realize you're being burned. So be careful, exercise all the caution you need. A leather apron would be nice. I have a flannel shirt that I wear over my shop shirt. And for some reason, when solder spatters, if it hits the flannel shirt, the flannel catches it for some reason. Instead of allowing it to burn through, it just sort of, the solder beads cool on the surface before they can get through and hurt me. But what I tend to do is I'll hold the rod and I'll squash the rod into place with my thumb, and I will bend it backwards, and then when I bend it further down to set the rivet, any gaps that would have appeared in here are compensated for, because the rolling of the metal, it's actually spring tension makes the two surfaces come together really nicely. So, but that's something I do in riveting, not when I'm soldering, because you can't touch the metal much. But I'm going to go ahead and stop this video now and finish the solder joint. Have a great day. Thanks for watching. Take care.